Hello students, today we will find the forces in this member which is exerted by 400 kgs at this point at joint B, and we will find the force in this member and in this member of this loaded truss. This truss is assumed to be it is in equilibrium. Okay, so for equilibrium there is summation of three type of equation: summation of moments at any point equal to 0 in equilibrium state, and summation of all forces in the all vertical forces in the truss, loaded truss, will also equal to 0, and summation of all horizontal forces will also equal to 0. Okay, so today we will find the forces in these members. First of all, I will find the reaction at this point. So if the 400 kg load is going downward and the string, this member, the force transfer to this member and transfer to this joint, and there will be a reaction force which will be 400 kg. Okay, so 400 kg will be reaction. There will be, so the reaction will be 400 kgs. Okay, so 400 kgs, or when I write it in newtons SI unit, so it will 3924 newton. Okay, the reaction which is exerted at this point, and also the reaction which is exerted at point C also will equal to 3924 newton. Okay, but the reaction at this point is directed toward left, and the reaction will directed toward right, because when the load is transferred to this point, the this will be the compressing force. So this force, this load will compress this member and compress this joint, and force applied to this joint, and the reaction force equal and opposite reaction force will be exerted at this point. So this reaction force will be in the opposite direction but same, and its value is also same. Okay, now I find the force in this member. So how can I find? So it will be find by joints method. Okay, so I will take joint B, which will be going to is easy, because joint B have one noun force, at least one noun force. So first of all, I will draw the joint B. So there is a member which is directed downward. This member is called force in member AB or AB member. Okay, and there is another member which is directed downward, which is F force in member BC. Okay, and there is another vertical force which is 400 or 3924 newton. Okay, so when I take joint B, this is joint B, this joint. Okay, there is one member, another member, and another force, 1 2 3. So I can resolve this is not either not horizontal, not vertical, and this also not horizontal or not vertical. So I will resolve it into its components. Okay, so I draw this joint first of all, and its vertical component like this. I resolve it into its component by head to tail rules. Okay, this is very basic concept, head to tail rule. So this horizontal component will equal to F force in this member. This will be equal to F AB. Okay, and this going to be equal to FAB this is its component, this is resultant, this is its component, and it's also this is its component. Okay, so FAB, here is cos with horizontal, there will be cos, and this is 30 degree, and the degree which makes with x-axis is 60 degree, so you will have to write this 60 degree. Okay, 60 degree. Okay, so the vertical component FAB sine 60 degree. Okay, I resolve this into these two components, and also I will resolve the another force which is this. Okay, so this is my resultant force, which is FABC. Okay, BC, this is my resultant force, and this is its vertical component, which is equal to FBC sine 30 degree. This is 60 degree, but with horizontal it make 30 degree. Okay, 30 degree, and and this is another horizontal component of this member, which is FBC, so it will become FBC cos 30 degree. Okay, now I can find by summation of equation. Okay, so like that, summation of all horizontal forces equal to 0. Okay, there is one horizontal force is this FAB cos 60, and the another horizontal force is this FBC cos 30 degree. Okay, there is no other horizontal force in this member, so can I write it as this is directed, if my force is directed toward left. Okay, if my force directed toward right, I will take it as positive. If my force directed toward left, I will take it as negative. So this is directed toward right, I will take it as positive. FAB cos 60 degree. Okay, and this is directed toward left, so it will negative FBC cos 30 degree equal to 0. This is equation. Okay, summation of all forces in x direction, in horizontal direction. So FAB will become equal to FBC cos 30 degree divided by, I will divide it, cos 60 degree. So from cos 30 or cos 60, from this we can calculate. I will calculate in my calculator. If I calculate it, cos 30 divided by cos 60, it will become FAB will become equal to 1.732 multiplied by FBC. Okay, so let's say this is my equation 1. Okay, so I will take another equation of equilibrium. So F summation of all vertical forces equal to 0. Okay, so if I take this, now I will take vertical force. One vertical force is this, so I will take my another pen. So one vertical force is this, and the another vertical force is this, and the third one vertical force is this. There is 3 vertical forces. 1, 2, this is 2, this is 3. Okay, this is third vertical force. So I will write these 3 vertical forces. Okay, so this vertical force is 3924, which is directed downward. I will the force which is directed downward will negative and directed upward will positive. Okay, so FBC, so 39, it will negative 39 to 4 plus this, both forces are directed downward, so negative FAB sine 60, so negative FAB sine 60, and the another force FBC sine 30, negative FBC sine 30 equal to 0. I will shift this to the right hand side, so at the place of FAB I can write 1.732 multiplied by FBC, so at the place of this I can write it 1.732, this is negative and this is positive, multiply by FBC and sine 60 degree. Okay, and negative FBC sine 30 degree will equal to 0. Now I can write it like I common FBC, sorry, I shift this number to here, 3924 plus 3924 Newton. Okay, so if I common FBC from these two terms, okay, so I common FBC, negative FBC, so I will remain 1.732 multiplied by sine 60, okay, negative, it will become positive because I common this. Okay, so it will become sine 30 degree. Okay, 3924. So if I multiply and add this, I will get FBC, negative FBC equal to, negative FBC will become equal to 2, from here it will become 1.5 and this is 0.5, which is 2, equal to 3924. So FBC is equal to 3924 divided by 2, 3924 divided by 2, which is equal to FBC, this is negative, FBC is negative 1960, okay, 62. Okay, so I calculate the force in this member, which is 19. This is my A, B and C. So this is equal to BC. BC member is this is C member, so 1962 Newton. Okay, so this is 1962 Newton, which is in compression. Okay, this will be in compression, because if the load is acting downward, and this member will be compressed and this member will be in tension. Okay, so if I, let's say it is equation 1, I put this equation in this FAB, 1.732 multiplied by FBC. So if I put this FBC, sorry, AB equal to 1.732 multiplied by FBC. The value of FBC is 1962. So FAB equal to 1.732, sorry, this is 2 multiplied by 1962. So FAB equal to, it will be equal to 3400 Newton. So I also calculate the load in this member AB, which is 3400 Newton, which is in tension. Okay, so this the remaining member which we will calculate the load in this the forces in this member. Okay, so I take joint A. Okay, I take joint A, joint A. Okay, if I take joint A, there is, I take this joint, so there is three forces. One force, if I take this joint, one is the reaction force, which is 3924 Newton, and the other is this, which is AB, FAB, which is equal to 3400, and the other is this, which is unknown. Okay, which is AB, AFAC. So we will find this. So I take summation of all forces, vertical forces, equal to 0. Okay, if I take a summation of all vertical forces, and the vertical member of this, vertical component of this member. Okay, I will take vertical component of this member. So I will take this F, it will negative F AC. Okay, and the vertical component of this member is, I have written this one. Okay, FAB sine 60. Okay, so the vertical component of this is FAB negative FAB sine 60 degree. Okay, equal to 0. So FAC will become equal to negative FAB sine 60. Okay, so FAC will become equal to, if I calculate this, FABI is now negative 3400. Okay, and sine 60 is, there is if I calculate it, 0.8. so FAC equal to 2900, approximately equal to 2900, and there is also a reaction force in y direction, which is equal to 3924. So this is positive in positive. So FAC will become equal to 981 Newton. Okay, the reaction force in this member is will be 981. Thank you very much.